4.2, simplifying rational expressions. So we know rational expression is that thing we call an algebraic fraction, okay, which simply means we can have expressions in the numerator and the denominator, right? So a rational expression is said to be in simplified form when the numerator and denominator have no common factors, right? It may be like taking 4 over 8 and saying, well, they're both divisible by 4. That's 1 over 2, right? That's the simplified form of a fraction, okay, when you cannot reduce it anymore. So here are the steps. Factor both the numerator and denominator completely. So the completely, really, we shouldn't have to say, right? Anytime we say factor, it's always completely. You know, so if you have a difference of squares and there's another difference of squares, or if you have to take out a common factor or something like that, that would be completely factored. Then, and this is the most important part, state the restrictions. So you factor numerator and denominator, then you state the restrictions, and that's only from the factored form of the denominator. So remember back when we did restrictions or non-permissible values, right? That was only from the denominator. And then divide out the common factors between numerator and denominator. Okay, so there's nothing to factor here, right? It's just 10x. So we can say x cannot equal 0. So whenever you see just a variable by itself, right, then that value of that variable cannot be 0. So in order to say monomial rational expressions, monomial is a single term. Now, if we do factor the numerator and denominator completely, we can just kind of say what goes into 10 and 15, well, 5, and what goes into x to the 5th and x, which is x. So the common factor would be 5x. Now, on stuff like this, I wouldn't expect you to show this work. You could just kind of do this in your head and work it down. But here's what it really looks like, right? So the common denominator, or sorry, the common factor, the one that goes into both, is 5x. So check this, right? 5 times 3 is 15. X times x to the 4th is x to the 5th. Okay, yep, that one works. 5 times 2 is 10, and then the x. That one works. Cross off the 5x's. Whenever you cross off top and bottom, always put a 1. And we are left with 3x to the 4th over 2. Now the restriction still holds. You can't put a 0 in there. I mean, you could say, but I can put a 0 in there, right? Because 0 to the 4th is 0, times 3 is 0, and 0 divided by 2 is 0. But then it's not equivalent to this rational expression, because in this rational expression, we can't put a value of x to be 0, right? It will make the denominator 0. So the original restriction comes from the factored form of the denominator. Okay, and they hold no matter what. So in this, this kind of basic grade 10-ish stuff. So, in this guy, we could just say, look, what goes into 24 and 40? And you can say, well, 4 goes into both of them. Okay, now it actually turns out that 8 goes into both. So, you know what? Here, let's do this. Let's go into here. Let's turn this on. Let's clear it. So I got 24 over 40. Let's go 24 divided by 40. Math. Enter, enter. Okay, and that's going to give me 3 over 5. So that's going to be equal to a 3 and a 5. Now, let's look here. And the way that I simplify variables is I say, who's the biggest? Okay, so the 6. 6 is the biggest. How much bigger than this is it? Well, 6 is 4 bigger, so we get a y to the 4th in the denominator, right? The denominator wins out. It's got the larger power of y. And it wins out by how much larger that power is than the power above, right? So 3 over 5y to the 4th. Negative 12 divided by negative 3 is positive 4. Okay, now we see, oh, and the power that's bigger is a 5th, and it's 1 bigger than that. So negative 12 divided by negative 3 is positive 4. X to the 5th is 1 more than x to the 4th. You just put an x, you don't need the 1. You don't need to show the 1. Simplified. Binomial numerators. So that means that the numerator may factor. The thing with a monomial expression is that you don't really have to factor anything. Okay, so greatest common factor. What goes into 30 and 40 is 10. The biggest power that's common is actually the smallest power, right? It's the one that goes into both. So 10x squared. How do I get 30? 3. How do I get x cubed? Put an x. Then a plus. When you're common factoring, right, however many terms you have in the original is how many terms you are going to have in the factored form. So to get 40, I'm going to put a 4. It's got an x squared. I don't need anything else. The denominator, and actually, you know what? We can state the restriction right here. X cannot equal 0. And we can say, you know what, if we're going to do this, let's say 10 and 25. So the biggest number that goes into 10 and 25 is 5. The biggest power of x that goes in is x squared. And 5x squared, to get 25x squared, we'd have to multiply by 5. So we're factoring this out, right? And now, whoa, that disappeared. Where'd it go? There it is. And now, I've got to watch what you lean on. And now, the x squareds cancel. 1 and 1. The 5 goes into the 10 twice. So we have 2 times 3x plus 4 all over 5. And we're done, right? But the original restriction holds, right? You cannot put an x as 0. Put an x as 0 in here. You can evaluate that, right? But if you put that same 0 in here, you'll end up trying to divide by 0. So we say these are equivalent. So for example, let's say x was 1. So that would give us 30 plus 40, which is 70 over 25. Okay, so it's so 70 over 25, math, enter, is 14 over 5, right? We'll put a 1 in here. 3 times 1 is 3, plus 4 is 7, times 2 is 14, over 5. They will be equivalent, right? They're equivalent rational expressions as long as x is not equal to 0. Okay, this guy here, factor the numerator. So biggest number that goes into 12 and 20. So 2 goes into both, not 3. 4 goes into 12 and 20. So 4 works. Okay, that's about it. So 4. And then the smallest power of x, right? Because you want an x that will divide into both of these guys. So 4 times 5 gives you 20. X squared times x. This will give you 20x cubed minus 3. Okay, because I want a 12x squared, so I'll get that, over 16x. And you know what? Hang on. We can state the restriction right up here. There's nothing to factor here, right? These guys, there's no factoring. So when you just have a single variable in the denominator, it's just that variable can't be 0, right? Restriction. X cannot equal 0. Okay, simplify. 4 goes into 16 4 times. X takes out the squared, right? So who's bigger? The x squared. How much bigger than x? 1 bigger. So we just get an x up there. Now, watch when you're writing. So that's a 1. That's just an x. So we have an x times 5x minus 3 all over, and all that's left down here is a 4. Keep dragging over. There's no space. All right, let's see what we got here. So we can start by saying m cannot be 0. Right? Anytime there's just a variable in the denominator, you just say that variable can't be 0. Okay, what do we got? So we've got a 10 and a 14. So 2 goes into both. That'll give us 7 and a 5. So 2m. And that's going to give me... Now, you know what? They're both minus. Let's pull the minus out front. So, you know, I'm going to rewrite that as soon as I find my erasey bit. Hey, whoa. I don't want that stuff. Not the eraser. That's not the eraser. Equal. So I need to go negative 2m. And then watch your signs, right? So to get negative 14, I just need a positive 7. To get m squared, I need an m. To get a negative, I need a plus, because I've already got a negative there. And to get 10, that'll be a 5. All over 14m squared. Okay. So negatives, always leave them up top. That'll be a 1. That'll be a 7. The bigger power is in the denominator. It's a squared, so we're going to reduce it to a 1. We cross that power off. So up top, I have a negative. Then a 7m plus 5. Then, on the bottom, I'm left with a 7 and an m. 7 and an m. Okay, so watch out with these. You can sometimes lose things as you're canceling, right? Just make sure you put little ones there and say, I'm left with a negative. I'm left with a 7m plus 5. On the bottom, the 14 reduced, I've got a 7 and an m. Here, so it's a monomial denominator, so a can't be 0. Biggest number that goes into 8 and 22 is 2. So this will be 4a plus 11. And in the denominator, 4a, cross off the 2, cross off 4 is a 2. So we are left with a 1, so we've got 4a plus 11, 4a plus 11 over 2a. And same restriction, okay. I don't need to restate it. As long as it's stated up here, that's good enough. I just need to remember that it applies down here. Although, you know what, it still applies down here. Even in this simplified expression, a can't be 0. Same deal here, m can't be 0. Over here, x could be 0, okay, but it can't be 0. That's the restriction. All right. We got 6 of these, and we're done. So this is factored already. And I'm going to show you a little trick here, right? There's something going on here. So you look up top, you've got 4 minus x. You look down in the bottom, in the denominator, you've got x minus 4. And you say, so it's like 4 minus x, x minus 4, they're kind of the same, right? Except this is a positive 4 and a negative x. And this is a positive x and a negative 4. So the signs are flipped. So here's what we can do. And I'm going to show you kind of the long way, and then after that you don't need to do it the long way. So I said, look, we've got our 3x, right? Let's factor a negative out of the brackets. Now you could put a negative 1 or just a negative sign. If I do that, then when you put a negative in front of a set of brackets, you change the sign of whatever's in the brackets. Okay, and at this point you're saying, great, that just looks worse. You got a negative sign sitting there and that. So it's, all right, well, hold still. So let's put these two together and get negative 3x. And let's write this in a different order, right? So instead of negative 4 plus x, let's write that as x minus 4. 18, x minus 4. Okay, hang on, wait, you're supposed to do restrictions, right? Let's go back here. X cannot equal 4, right? If x is 4, that's going to be 0. So there's your restriction. That's really supposed to have happened first, right? As soon as you get the factored form, this is a factored form of the denominator, state the restriction. Okay, see these guys? They're the same. Cross them off. 3 goes into 18 6 times. We are left with negative x over 6. Okay? Now, I'm just going to show you here, that's the justification. This is why that's happening. This is why, because you can factor a negative out of there. So what I really want you to do is this. 3x, 4 minus x, 18, x minus 4. I want you to just look at these two and say, these guys are the same, except their signs. So if I cross them off, I'll put a 1 there. I'm going to put a negative 1 up top. So I can cross them off. They're the same, but their signs are flipped. So what I do is just cross them off, eliminate them, right? But change one of the signs to a negative. And that's really the same as what happened here. They get crossed off, but there's a negative here now. So now this is negative 3x. Negative 3x over 18. Right, and then that's going to become that. So you don't need to go through this. You just do the recognition of, hey, they're the same, except their signs are exact opposite. That's not going to work if this is 4 minus x, and this is negative 4 plus x or something, right? Because then, no, that would be the same. If this is negative 4 minus x, then they don't have opposite signs, right? That would be a negative. That would also be a negative. So, same two terms, both signs opposite. 4 minus x, a negative 4, and a positive x. Then, cross them off, put in a negative 1. Okay, this is factored, so we can state restrictions. X cannot be. So let's start here, right? If you have an x squared, then x can't be 0. Okay, remember this? Take the opposite sign, negative 2 over 3. Right? Now, if that's freaking you out, you're going to wait a minute. Then just go 3x plus 2 equals 0. Set the denominator to 0. Solve. Get the non-permissible value. X is negative 2/3. That's your non-permissible value, right? But then state it as a restriction and just say x cannot equal negative 2/3. Okay, are these the same? 2x plus 3 and 3x plus 2. So I have a 2x, but here I have a 3x. I got a plus 3, here I got a 2. And we could say, no, they're not the same, right? It's not like opposite signs or anything. It's just the numbers are opposite. So, you know what we do? Cross off the 8x squared. Cross off. When you cross stuff off, put a 1. What's left? 2x plus 3. And at this point, we can drop the brackets. We don't need them anymore. Nothing's being multiplied. And in the denominator, 3x plus 2. And that's it. We're done, right? Along with the restriction. Okay, so this is actually a little bit easier than it looks in the sense of, okay, I don't need to change signs, cross off, put in a negative. They're just different terms. That's a 2x, that's a 3x. Okay, we're done. Those are not the same term. Next up, 3x squared minus 15x over 6x minus 30. So the first step is factor. So 3x, x minus 5. Okay, I'm not going to go through all detail-y factoring stuff now. It's just you need to be able to factor. That is not a 50. That I will change. Okay. So, step 1, factor numerator denominator. Step 2, restrictions from the factored form. So x cannot be 5, right? That would make x minus 5, 0. X minus 5, cross off. 3, that's a 2. Okay, be careful, I got a 1, an x, and a 1. That's x, and on the bottom, I have a 2. So x over 2. That is the simplified form. Okay, and the restriction, right? You try and put a 5 in there, you get a 0. You put a 5 in here, you just get 5 halves. But remember, the restriction is still valid. This will not be the same as this if x is 5. Any other value is fine. You put x as 100 in there, you're going to end up with 50. I'm not putting x as 100 in there, but you would end up with 100 over 2, which is 50. You put a 10, did it again. Put a 10 in there, that'll be 5. Put a 10 in here, that'll be 300 minus 150, which is 150, over 60 minus 30. 60 minus 30 is 30. 150 over 30 is 5, right? And 10 over 2 is 5. So they're the same. This is a sum of squares. You cannot do anything other than a greatest common factor, but you can't do a greatest common factor with that. Factored form, state restrictions. That's a negative, and I don't have room, so I got to erase this. Getting good with the eraser. There we go. That's it. You're done, right? This does not cancel because there is no factor here of an x plus 4, right? If there's an x plus 4, then you got to put an x minus 4. That'll give you a negative last term. This sum of squares does not factor. Okay. This guy, we're going back to the beginning here. So x squared is your greatest common factor. 5x, right? X squared times 5x will give you 5x cubed minus 1. Nice. Look at it. Where's the undo? There should just be a... I can't control Z it because the keyboard's on the other side. It's a tablet. It's flipped. Alright, let's try that again. 5x minus 1. 1 minus 5x. Okay, first step. Restriction. Now, when they're written like this, they're a little weirder, right? Because the x isn't first, so we can't sort of like, oh, let's flip this and do this. So I find it easier, let's just go over here. Just say 1 minus 5x is 0, right? Negative 5x is negative 1. X is 1/5. So the restriction is x cannot be 1/5. Okay, nobody cares how you do restrictions. Just state it. Don't throw in extra restrictions. There's no like x can't be 0 because if I put a 0 in here, that'll be 0. It's fine. Numerators can be 0. That's not a problem. All right, here's the deal. 5x minus 1, a positive 5x and negative 1, a positive 1 and negative 5x. Throw that in brackets, cross that off, but put a negative 1. That's all you have to do. You don't have to justify anything further, right? You just say, hey, these are the same, cross them off, that's a negative, and the answer is negative x squared. Okay, that's it, we're done. Negative x squared, with the restriction that x cannot be 1/5. All right, last one, we're done here. Equals, all right, that factor is right. That is a difference of squares. X plus 5, x minus 5. This is two terms. Two terms is a common factor. From the factored form of the denominator, we state the restriction. X cannot be negative 5. Simplify. Cross off, put a 1. Cross off, put a 1. What do we got? Up top, I got a 1. I got an x minus 5. Down here, got a 4. You don't really need the brackets. It doesn't really matter. They're there, they're not there. It's fine. Okay. If there's a number in front, they got to be there. So x minus 5 over 4. And again, if you want, you can repeat the restriction. Okay. That's it. We're done. It's a shorty.